Hey guys, welcome back to Silly Codes. Today we'll be looking at Project Euler Problem 2. So before looking at the problem, I'll first walk through what Fibonacci numbers are and the algorithms of finding Fibonacci numbers. In most simple terms, the Fibonacci sequence starts with 1 and 2 as the first terms, or sometimes even 0 and 1, and the value of the next term is always the sum of the previous two terms. So according to that definition, the first and second terms of the sequence should be 1 and 2, and the third term of the sequence should be 1 plus 2 equals 3, and the fourth term is 3 plus 2 equals 5. And so on the sequence goes, adding the previous two terms like 1, 2, 3, 5, 8, 13, 21 and so on. Okay, so let's think about a recursive approach to find a Fibonacci number. First of all, we know that the sixth Fibonacci number is equal to the fifth and fourth Fibonacci numbers. So if I know what the fifth and fourth Fibonacci numbers are, then my target will be completed. But the thing is that we don't know what the fourth Fibonacci number and fifth Fibonacci number is. So if I think about this, the Fib of 3 is equal to Fibonacci of 3 plus Fibonacci of 2. And the Fibonacci of 4 is equal to the sum of Fib 3 plus Fib 2. And so on. And finally, at last, this tree will reach either Fibonacci of 1 or Fib 2. And this, my friends, will be our base cases for the algorithm. So this is the code for the algorithm in Python, as you can see. So the first part is the base case of this algorithm. So if n equals 1 and n equals 2, we just return 1 or 2. And in the else block, this is the recursive part of the problem. So this code executes just like the recursive tree I have shown previously. And another thing we should know is that in theory, every recursive algorithm can be written as an iterative algorithm and vice versa. So regarding the iterative approach, we'll jump straight into the Python code of the algorithm. So the first part of the code is just as same as the previous one. And the new thing we have here is this for loop. So basically what this for loop does is, for each iteration, finds the next Fibonacci number and kind of updates the A and B variables, which should always store the previous two Fibonacci numbers. And after the loop is over, the variable B should contain the n Fibonacci number we are looking for. So there are some facts regarding these two types of algorithms. The thing is that recursive algorithms are generally easier to code, but they are sometimes inefficient. But iterative algorithms are more efficient, but needs more lines of code. Regarding the two time complexities of these algorithms, the recursive algorithm is O of 2 to the power n time complexity, while the iterative algorithm is O of n time complexity. Basically what this says is that the iterative approach is more faster than the recursive one. Okay, now let's get into the coding. I have already written the recursive and iterative functions, as you can see here. So according to this question, the thing I need to do here is keep adding the Fibonacci numbers until the values of the Fibonacci numbers exceeds 4 million. So first let's create the result variable as res and set it to 0. I'm going to keep adding the Fibonacci numbers to it. And I'm gonna set n equals to 1. And to implement this logic, it's better to use a while true loop. So inside the while true loop, I'll get the Fibonacci number for n. And n is going to be incremented in every iteration. Okay, so according to the question, when the Fibonacci term starts exceeding 4 million, that's when you should break the while true loop. And also, we should not forget adding each term if it's even. So this is how we find if the term is even and if it is res plus an equals term. Okay, so now the code is complete. If we now print the result, we'll get an answer like this. So I use the iterative function for solving this. If we use the recursive function, we should get the same answer, but it would take a little more time. Okay, so that is how we solve Project Euler Problem 2. Really, the core of this problem is understanding the algorithm of finding the Fibonacci numbers. And I'll see you guys again in another video. Thanks for watching Silly Codes. Drop a like, comment and subscribe. And peace.